Hello, my name is Kelvin Addo, and this is a video presentation of my Physics 2211 Lab 1. The purpose of this lab was to record a video of an object in motion, analyze the recorded video, create a computational version of the constant motion, and compare the observed and computational versions. The fundamental physics principles observed in this lab were Newton's first law of motion and Newton's second law, which states that force is equal to mass times acceleration. The first part of this lab required us to record an object in constant motion. As the picture shows, the marker highlighted in red serves as an object which is exhibited in constant motion, and it serves as the system for our experiment. Everything else highlighted in green is the surroundings of the experiment. The hand in the picture applies a force to the system, which allows for the object to begin motion. This exhibits Newton's first law of inertia, which states that an object at rest will stay at rest. When the object begins its motion, it is not stopped for the rest of the video, which exhibits the second part of Newton's first law of motion, which states that an object in motion will stay in motion until interrupted by another force. This fundamental principle of physics can be shown through the position versus time graph extracted by tracker from the motion of the object. As shown by the graph, there's a continuous increase showing that there's a continuous velocity in the motion of the object. This uninterrupted motion proves Newton's first law of inertia, as there is no dips in the graph showing that the object remains in motion and there is no force that interrupts that motion. The second part of the lab was to create a computational code that will predict the motion of an object with constant speed. In order to do this, I copied the code provided in Canvas and pasted it in GlowScript. I then changed the ball velocity in the code from 0 to the slope of the observed motion divided by the change in time. And then I changed fnet to 0 in order to provide results. As shown by the first part of the analysis, the second part also requires the computational version to have a system and surroundings. As shown by the blue ball highlighted in red, this is our system and everything else is our surroundings. The effect of setting fnet to 0 is fulfilling Newton's second law, F equals mass times acceleration. Fnet in this case being 0 shows that there is no acceleration within the system, meaning there is a constant motion. And this is exhibited by the graph of the computational version of this analysis. Similar to the graph of the first part of the experiment, the graph shows a consistent increase, which shows that there is constant motion. This also fulfills Newton's first law of inertia that states that an object in motion stays in motion until interrupted by another force. And in this case, since we put fnet as 0, we know that this object has no interrupting forces and exhibits constant motion. However, differences between the two graphs are shown when you put them together in a graphical analysis of both. As you can see, when both graphs are put together, there is a higher velocity shown in the computational analysis than there is in the observed version. We know this is true because the computational analysis covers much more distance than the observed version does. This can be due to an error in calculations when put into tracker of the observed version, or this could simply be unpreventable errors that happen naturally as a result of natural motion. So to conclude, the results or data analysis given by these two versions of the lab, the observed version shows a constant velocity over time, but less velocity because there's less position covered as compared to the computational version, which has a higher velocity as there is more position covered. Now to compare the results if the position was reversed. If the position was to start from the right to the left as opposed to the left to the right as shown in the picture previous, then results would have been in the negative. Positioning would have been in the opposite direction, meaning velocity would be constant but moving in a downward trend. This is the analysis and presentation of Lab 1, and thank you for listening.